everybody. Thank you very much. Welcome to my presentation, and bye to the gopher, I guess, on creating a CLI manager, and really any CLI with the Cobra library. Now, I know that this is a pretty difficult slot in general. It's also hot. People just, lunch is kind of kicking in. So hopefully my content is enough. But if not, hopefully I'll be swinging in some memes and some fun things throughout. So to try and keep things a bit interesting. So I want to describe a morning to you. I want to see whether it's relevant, whether it resonates with any of you. You sit down to work. You look at whatever support tasks you have. Maybe that's Slack messages. Maybe that's tickets on some ticketing system. And you start to organize them. You start to see what do you have for the day. So some of them are slam dunks. They're easy to handle. They're interesting. You know exactly how to take care of them. Then you have the black swan events. We all have them. It's the days where you get a message and you just want to close your laptop, go to the beach, cry because it's just going to be a bad day from there on. And then there are the ones that are just a bit annoying. They're not often enough that it's your top priority, but it's just annoying when they ask you them. And it's something that really can be solved with some very simple tooling. And it's really those problems that I want to focus on for today. I want to try and help guide us together. Think about how we can solve all of those problems collectively, bit by bit. Ideally, I'll take you from wanting to explode like that to telling the customers that not just you, but that they can take care of it themselves. And this may be more relevant, especially for internal tooling, but it will also be relevant for people who have to do things like talking to APIs or even changing things on your customer's computer. So just to give a bit of a sneak peek, over the course of the past year and a half or so, at AppsFlyer, we've used this methodology to do a whole bunch of things, whether that was building a package manager. We standardized container builds. We fixed Jenkins configurations. We stopped people from overloading our Vault server. And we also manage our AWS access all through this kind of same framework. But that's getting a bit ahead of myself. So hey, I'm David. I'm a software engineer in the platform group at AppsFlyer, where I work on their build and deployment systems. I'm also a maintainer of the Build Packs project, the cloud native Build Packs. And I've previously worked at VMware, Google, and Goldman Sachs. For those who don't know, AppsFlyer is a 10-year-old Israeli startup. It's raised over $300 million in funding, and it's servicing 65% of all mobile apps. And you've definitely encountered our tech under the hood. But what do we actually do? Basically, we give tools to marketers and we help them understand how effective their ad spend is. So what that means is that if you click on an ad on your phone, it's most likely going through our server first to tell the customer exactly how effective their ad was. One example you may have seen was the Coinbase ad, a floating QR code in the most recent Super Bowl, which used our tech under the hood. Our R&D department is 400 plus. It's a very heavy focus on microservices, and it handles more than 2.5 million events per second. And importantly, AppsFlyer is hiring. So you may have noticed there are a lot of people here in sweatshirts. We also have our Gopher round. So please stop by the booth, talk, and see whether we can be relevant for you at any point. In the course of the presentation, we're going to cover 5 main areas. Number 1, I want to describe some of the pain points that we found. Number 2, why was Cobra a relevant solution for us? Number 3, how did we practically design and implement the CLI toolchain that I'm going to describe? Number 4 is the fun part. That's where we actually write a demo CLI together, and I'll try to keep it pretty short and interesting. And number 5, I want to share some insights with you on the things that we've learned over the course of the past year and a half. So let's get started. As I mentioned, I work in AppsFlyer's platform division, and our mandate is to allow our engineers to do non-trivial things in a very trivial way. What that means is that we strive to maximize our engineers' productivity however we can. So specifically, my team creates and supports tooling across all of R&D to build, to test, and to store products. So this includes things like supporting GitLab, Jenkins, Artifactory, and any of the containerization efforts within the company. In addition, we also create and we support a testing tool that the entire company uses to essentially make sure to test all of our microservices. That tool is called Namespaces, and as I mentioned, it's used to test microservices. What that means is that it allows teams to spin up environments that with all of the services that their service interacts with, so they can make sure that any changes will be very accurately tested, and they can know that production is actually working. Now, that tool is exposed as an API, but we also created a CLI to interact with that tool. Very innovatively, we call that AF CLI. But we noticed that ours wasn't the only CLI that was created for that tool. There actually were 4 CLIs. And interestingly, the engineers used these tools differently when they were doing it locally versus when they were doing it, let's say, in any of our CI environments. And that really got us thinking something clearly was up. What do we do with the fact that there's too many tools for this tool? Clearly, there's only one option, right? As engineers, we all know you have to write it yourself again. So when we thought about it, there were 4 really main issues that we could distill from this whole process. Number 1, there clearly was a problem internally for discovering previously built tools. People just didn't know what was out there. Number 2, engineering waste. We all know engineers are expensive, so there's no need to waste their time in creating new tooling if it adequately supports their needs. Number 3, there was environment-specific tooling. People needed to solve different problems when they were interacting with our tools, whether locally or in one of our CI environments, and that was a waste. Ideally, our engineers should only need to know one way of interacting with the tool, and that is it. And lastly, there was a high general tooling cost, which means that all of the engineers who were creating these CLIs or different tooling had to deal with very similar problems. That includes things like auto tagging, releasing, documentation, and things like that we could hopefully try and solve for them with one fell swoop. So it was clear that we needed a change and we needed to do something that would, vault the business onto the next level. So we decided that we should have 3 main principles with our solution. Number 1, it needed to be maintainable. If we were going to create, let's say, a tool chain for all of our engineers to use, we needed to make sure that it was very, very intensely tested because everything is relying on us. Number 2, it needed to be platform agnostic. We needed to make sure you could use this tool regardless of where in our company you were using it. And number 3, we needed to make sure it was extensible. We had to limit the users as little as possible and ensure that they could get as much out of it as they could. So let's start understanding where Cobra can fit in. For those who don't know, a CLI, what you see before you, is a command line prompt, a command line interface. Basically, it's a program that you can run without a graphical interface. Why is that useful? So number 1, it's useful because you don't need to actually create a front end. That's less work. But number 2, it's also useful for scripting purposes because you're able to create and to do something where even when you don't necessarily have the opportunity of clicking on buttons, let's say in an automated environment. So what then is Cobra? Cobra was created by Steve Francia, SPF 13, who's pretty much a legend in the Go community. And he was the product manager at the Go team at Google, and he really helped direct the community a lot. Cobra in general is a library that provides a very simple reference for creating powerful CLIs. Some of the features that it provides are sub-commands, so you can have you can have multiple commands within your app. It also provides for easy parsing of flags and automatically creating documentation, help commands, version commands, and things like that. There are a whole bunch of big CLIs that use that, but some of the most commonly known ones are kubectl and the GitHub CLI. So this before you is pretty much a sample implementation. This is a hello world. What you do is you create a cobra.command, which is pretty short when you look at it. And in the main, all that you do is you execute it. And that's all you need to get running. And now you see me running it. First I built it, then I'm running the version command. I'm running the help command so you can see what it does. And hello GopherCon, it works. So obviously we're engineers, testing is very important. And we can easily create a command, you can run it, and you can validate that there's no errors and that the output is as expected. So before you see a sample test, and over here I'm running the test, and you can see that they pass. Now. So now that we understand a bit about Cobra, let's understand the design of our CLI. So the vision of the CLI was basically to be a package manager a la Brew for Mac or apt-get for Linux. But we also wanted to serve as an entry point for those plugins, similar to how kubectl works with their plugins or Vault. It's important to note that this is different from Go plugins, which also is something that's built into the language, but for whatever reasons, we didn't want to use that for these purposes. So what that meant is that there are going to be 4 main purposes of the tool. Number 1, you needed to be able to list the tooling that existed. Number 2 and 3, you needed to install and to update any of the plugins. That combined with deletion is pretty much CRUD. Number 4, you also needed to be able to call the plugin. We want it to be the entry point to actually interact with any of these plugins. And lastly, we also exposed a library command, the add command, the plugin's new deploy command, which basically adds a hidden deploy command to any of the plugins that people added that was in charge of actually deploying it to the right location. Now, that's a lot of words. Let's try and understand it a bit deeper. So you got an engineer. Any engineer has a good mustache, right? So he's creating a plugin. As you see, it has our publish command added. That's what it says in the post-it note. So they compile that command, and then they run that compiled plugin's deploy command. That command creates a YAML file that essentially lists all the available commands within the CLI, and it puts that plugin together with the YAML file in our Artifactory instance, in our Artifact repository manager. So that now looks like this. You can see that we have different folders for each of the different binaries, and essentially we're able to organize our plugins and the versions in a tree-like structure there. So how do we use those plugins once they're in the cloud? It all starts with the listing process. What we do is we use the querying language for Artifactory called AQL to get a list of the plugins and versions. We're able to parse the directory tree, and then we can tell the users that these available commands exist with these versions. When you install, it's very similar. What it does is it first looks and it gets that plugin from our Artifact repository manager, and then it downloads it to a local directory, to the .af directory. It parses the YAML file that's there, and then it adds that parsed YAML file into a local file that it uses for a state. And so when you then call AF and then your plugin, whatever that plugin is, now it knows how to interact with it. It knows the available flags, and it's able to send everything, essentially shell out and run that command as necessary. So that's a bit of the basic diagram, but let's get to seeing how it works in practice. So this is the help command. You can see, I don't know how clear it is over here, but I have a whole bunch of plugins that are currently installed, and it also tells me what versions are available so I can update it. This is the automatic documentation that we have. And now let's get to the plugins. So this is one plugin called the Images plugin, and it's used to build containers using build packs. I actually spoke about this at the Open Source Summit if you want to look at that on YouTube. And this plugin basically allows our entire organization to structure how we construct our images and make sure that people are building it without needing to create a Docker file or doing anything difficult. All that they do is they code their service, and then they run AF images build. Similarly, let's say people want to get a token for our secret manager. So all they would need to do is AF vault login, and that would give them the token they would need. Remember that testing tool we mentioned, namespaces? So similar to that, we created a different plugin just to interact with that testing tool. And you can see that we're using that plugin to create and to see the status of an existing environment, spinning up whatever resources we need. So now one of the big elements of this whole ask was that we wanted to use it not just locally, but also in our CI. So we distribute our AF CLI as a Docker image. So our users can essentially just can install a plugin and run it in their CI just by defining that as, in this case, it's a GitLab task, but it really is used across all of our CI environments. As part of this, we also have a template for new plugins to really simplify the creation of a new plugin and make sure that it's very simple so we can solve a whole bunch of the boilerplate issues that they had to deal with. I feel like I'm speeding through this a bit fast, but this is kind of the basic structure of how an app looks. You can see, we have most of the actual command code lives in the command directory. If there's more complex logic, it will be in a package directory. And we have tests, etc., that you're able to use to ensure that the logic is adequately tested. So I've talked about tests a little bit, and you can see you can write some simple tests. But what do you do when you have something that's a bit more complex? That when you need to add some real logic to it. So one of the key tools that we use for that is Go interfaces. Here you can see we defined an interface, an actor, with a function that it's supposed to do. In this case, it's supposed to do something fabulous. And we also have an implementation of that interface. But what we can also do is we can use GoMock, and you can use GoGenerate to create a mocked interface of that implementation of that interface for testing purposes. So when it comes time to using that, when we define the more complex command, we use dependency injection to supply an implementation of that interface. And here you can see this is how we do it in our main, right? We define one of those complex, those actual implementations of the interfaces, and we pass it in to the command creation. But what this allows us to do is that now in our tests, we can define what we call a GoMock controller to look at the interface, at the test implementation, and we can expect that whatever we define from our interface will be accurately called. And with that, hopefully, even the more complex tests pass. So this may seem like a lot of work for little gain, but what this really allows us to do is to separate our concerns in two main fashions. First of all, when it comes to writing our plugins, what we're able to do is we can separate kind of the command logic, parsing flags or worrying about main commands from the real execution logic in a very clean fashion. And we can make sure that everything is really well tested. And importantly, when we write plugins, we can write really small, focused plugins to take care of whatever our small business needs are and make sure that we're moving as fast as we possibly can. And with that, there's a lot of trade-offs. People can ask why we didn't use a whole bunch of different libraries, and there are quite a few for actually creating CLIs like this. But in our case, we really wanted to use a stable, maintained library that we already had experience with, and Cobra for us was the obvious choice. So ultimately, what we're left with is a solution that fulfills all of our solution principles, and it gives us the flexibility that we need. It's really, really well tested. We haven't had any issues with it since we created it. It's platform agnostic, so all of our users do use it across all of our environments, and it's extensible. People just create CLIs without asking us. Really, we've tried to really empower our developers to move as fast as they can and make sure that they can create whatever they need simply. So now that we kind of went through the whole underpinnings of the system, I want to actually work on a CLI with you. Over the course of the next few minutes, let's write a demo CLI together. So for anybody who wants to look at this later or right now, this is the repo, GopherCon CLI. And basically in the README there, you'll see that there's a whole bunch of the background for what we need. So let's go. So in this case, all that you can see is we have a very, very basic project. Now in the README, we're going to describe what we're going to do. And that is, we're going to first create some initial functionality. Then we'll sprinkle some AI in, because AI is always useful. We'll add some styles so that you can print it with some pizzazz. If we have time, we'll try and add a mocking interface so we can test it really thoroughly. And we'll run it so you can see how it works. So the first thing that you need to do is you need to first gomod init your project. In this case, I already did it in our gomod file. Then let's go get a few of our actual libraries we're going to use. So in this case, we're going to get Cobra. Let me just make sure this is being seen. We'll also go get the GPT-3 library that we're using. In this case, since ChatGPT does not yet have a stable API, I figured it wasn't good to do it as a demo. We'll also get a require library that we'll need for our tests, as well as lipgloss, which is a library that we can use to print things out nicely. And lastly, if we get to it, we'll also add in the library that we need for mockgen, for mocking. Okay, so now that we have all of our requirements, we can create a command directory. We can create the file that's going to actually house our command. And let's touch also a main.go. Beautiful. So in this case, you can see here it's updating. So we have a root.go. What we're going to want to do is we're going to want to create a command package, and let's create a new function. So func new Joker command. And ultimately what we're going to be doing is we're going to be creating a Cobra CLI that returns dad jokes, because why not? So let's return Cobra.command. And if you look at this, there's a whole bunch of different options that you can use for actually, for supplementing your CLI. Most of these we're not going to use right now. But as you can see, there's a lot of different things you can do in terms of arguments, validation, and things to do pre and post your run. So in this case, what we're going to want is use version the run.e, and short is also what we're going to need. Okay, so use, well, this is the actual command. So Joker is what we're going to be running. Short, this is the short description of what we're doing. Joker is a CLI that returns corny dad jokes. The version, let's say it's 001, and the run function. So in this case, we're defining a function that in this case is going to, let's print hello GopherCon and return nil. Beautiful. So now that we've done this, now let's actually create and run this. So this is in the main. We're going to want to run a main function. So the root is going to be command.newJoker command. And if, let's actually execute that root. If errors equal to root.execute and error is not equal to nil, then let's fprint to standard error the error, and let's os.exit1. Beautiful. Let's see whether this works. Make run. And hello GopherCon. We get this far. So now that we've done this, you see we actually have something. So we can't go any further. Let's create a test. So test for empty test file. Let's do it in a different package for white box test, for black box testing, text new Joker command. We're going to want to define a new command and new Joker command. We're going to want to create a buffer. This is so that we can actually validate the output. Let's root.setOut the buffer. Let's require no error root.execute. And now we're requiring that it runs without any issue. Now that we're here, we can require equal. Let's say hello GopherCon with strings.trim space and with buff.string. Let's make sure that this actually works. Make test. And it works, passes. Great. So now we have a test, we have code, we have something running. So now, what do we do from here? So what we'll do is we'll create a GPT-3 client. And with that client, we will ask for a dad joke. So in this case, go GPT-3 client, new client. I already got a OpenAI key, so I'm just exporting that as a variable. So get env, OpenAI key. We're going to need a context, which is context.background. And the request is going to be go GPT-3 completion request. Fill all fields. So you can see there's a lot of different options that they have present. In this case, what we're going to want to do, for the people who were at the AI talk, she explained the different options kind of a lot better than I can. But we're going to use the Da Vinci model. That's what I found best. Say, tell me a corny dad joke. Max tokens, this is the number of words the max number of words it will return. Temperature is around how random it can be. And that should be enough for what we need now. So now we're going to be able to get a response and an error if we run client.createCompletion with the context and the request. And as we all know, as gophers, if there is nil, then you have to return it. Great. So now we have this. Let's get the answer. The joke is going to be response.choices 0.text. And that's command.println of that joke. And hopefully this works. As a warning, when I tried it on this Wi-Fi, it works around half the time. So we'll see whether this is the half or not. And yeah, we got it. Okay. So in this case, we have a joke. What did one ocean say to the other? Nothing. They just wave. And that's 5 minutes left. Okay. So just to print to make this a bit nicer. So in the README, I have we use a library called lipgloss to just print this out a bit more nicely. So we can define a style using lipgloss.style, and then we can do command.println with style.render. And then I believe it is the joke. And ideally, this should be all we need. Let's also do strings that trim spaces, because I know that it adds some additional white space. And let's try running this again. And ideally, we should see that it has some nicer output. Beautiful. So let's see, I guess at this point, we probably have 3 minutes or so. So I'll wrap it up here, but on the README, you can see what I also end up doing is I define an interface with using mockgen to define a mock, and we change the test to actually use that. So you can create some more intense functionality. But now that we did that, let's go back. So now finally, once we're here, let's go through some of the insights. So some of the things that we learned is, first of all, that sharing is caring. I came onto this project, really, I joined AppsFlyer as a maintainer of a Cobra library. So for me, this was very simple. But we really needed to share a lot of this context with the other engineers, both in the team and the company, to make them understand how exactly this whole setup would work. Number two, it was really important for us to find collaborators and partners. In this case, we had other teams, both internally in the platform and elsewhere in R&D, who really wanted to both create other plugins and who wanted us to support their tooling. And this really helped us make sure that we were making the right choices as we moved forward. And lastly, not all growth is equal. We really didn't see the growth, the traction we expected with our tool initially. It really took until some of the other teams released plugins, like that Vault plugin that I mentioned, before our takeoff really grew tremendously. And so you really shouldn't be discouraged if something happens, because really you never know. Ultimately, we all hope that our tools will succeed. So with that, thank you all so much for coming. I tried to really help you understand how a framework for how we at AppsFlyer really solved some problems. But what I hoped you gained from it was how you can also use Cobra and similar libraries to solve problems of your own. So thank you so much, and looking forward to talking. If there's any questions, feel free to ask.